Hi, my name is Mark, and welcome to another tutorial. This time we're going to talk about computer network devices. Now, first on the list is the router. A router is a device, like a switch, that routes data packets based on their IP addresses. Router is mainly a network layer device, and routers normally connect LANs and WANs together and have dynamically updating routing table based on which they make decisions on routing the data packets. As you can see here, these are examples of routers, and I'll show you some other pictures of routers. So these are some examples of routers, which includes the wireless routers also. Okay, so this familiar setup, this one, where you have a wireless router here, wireless router. Okay, so that's for routers. Next on the list are repeaters, hubs, and switches. These devices connect network together so they can function as a single segment. So first one is the hub, okay, the repeater. The repeater operates at the physical layer, which is the layer 1. Its job is to regenerate the signal over the same network before the signal becomes too weak or corrupted so as to extend the length to which the signal can be transmitted over the same network. So a hub is actually a multi-port repeater. That means to show you an example of a hub is this. This is the hub. You have multiple ports. A repeater only has two ports, one for in and one for out. Okay, so for a hub, you have multiple repeaters. Sorry, you have multiple ports. Okay, now a hub is basically a multi-port repeater, and it connects multiple wires coming from different branches. For example, the connector in star topology, which connects different stations. Now, there are two types of hubs, the active hub and the passive hub. So the active hubs have their own power supply and can clean, boost, and relay signal along the network. It serves both as a repeater as well as wiring center. These are used to extend maximum distance between nodes. While the passive hub collects wiring from nodes and power supply from active hub. That's why it's called passive hub, because it collects also the power supply from the active hub. These hubs relay signals into the network without cleaning. Okay, please take note of the word without cleaning and boosting them, and can't be used to extend the distance between nodes. So why do we say clean and boosting? This means because, as in with the previous discussion we had, signals that passes through these wires are subject to noise. Noise means unwanted signals. So in active hub, it cleans and boosts the signal, while in the passive hub, it does not care on cleaning and boosting the signals that passes through it. Okay, so those are the two types of hub, the active hub and the passive hub. Now, what about bridge? Okay, a bridge connects two separate Ethernet network segments. It forwards packets from the source network to the destined network. A bridge operates at the data link layer, and bridge is a repeater with an add-on the functionality of filtering content by reading the MAC address and source destination. So again, I would like to highlight this word, with an add-on functionality of filtering content by reading the MAC address of the source and the destination. So with the Repeater, it doesn't really care on information of the MAC address, but with the bridge, it filters out and it takes note of the MAC addresses of the destination and the source. Now, there are two types of bridges. These are bridge transparent and the source routing bridge. So in the transparent bridge, these are bridge in which the stations are completely unaware of the bridge's existence, whether or not a bridge is added or deleted from the network. Reconfiguration of the stations is unnecessary. While in the source routing bridges, these bridges routing operation is performed by the source station and the frame specifies which route to follow. By the way, to make this more real for you, because you might be questioning what does a bridge really look like, okay? So a bridge is actually, an example of a bridge is the switch. Okay, this is the switch, and this is also a switch. Now you would ask a question, you might ask the question that hub actually looks the same as the switch. Yes, it looks the same, but it works differently. Because okay, by the way, if you're asking also, why is bridge a switch or a switch is a bridge? So, same as with repeater is to a hub is to repeater, same is the switch to a bridge. Why? Because the hub is a multi-port repeater, while the switch is also a multi-port bridge. So switch again, just like to reiterate it, that switch is a multi-port bridge. And the main difference for that is its functionality. And to make it even clearer, if you compare a switch with a hub, is that a switch is an intelligent device compared to a hub, just as a bridge is an intelligent device compared to a repeater. That clarifies it. So this switch, okay, the switch is a multi-port bridge with a buffer and a design that can boost its efficiency. So a large number of ports imply less traffic and performance. A switch is a data link layer device. The switch can perform error checking before forwarding data and makes it very efficient as it does not forward packets to have errors and forward good packets selectively to correct port only. So this is what makes the switch or the bridge intelligent compared to hubs and repeaters, because this switch filters and performs data forwarding, makes it efficient data and the packets to flow through the network. In other words, the network where you use, if you compare two networks where one network uses a switch and another network which uses a hub, the network which uses the switch has lesser collision, or the traffic is lesser, so that means data packets go through the network efficiently and faster. Okay, so that's the main difference between a switch and a hub. So if you're asking, how about today, sir, what do we usually use? Do we use the hub or the switch? We use the switch. Okay, we don't use the hub anymore. Okay, so how about gateways? Gateway is the same as the name suggests, is a passage to two networks together that may work upon different networking models. And they basically work as the messenger agents that take data from the system, interpret it, and transfer it to another system. Gateways are also called protocol converters and can operate at any network layer. Gateways are generally more complex than switch or a router. So an example of a gateway is this one. Okay, a gateway connects entirely different networks, work upon different protocols. It is the entry and the exit point of a network and controls access to other networks. So this is an example of a gateway. And next device is the network interface card, or the NIC. So this is what you usually find at the back of your system unit. Okay, you see this kind of port. So this is the network interface card port, okay, or the Ethernet port, and this is where we plug in the RJ45 that is connected to the UTP or the STP cable. So the next device are the patch panels and the patch cables. So the patch panel is a group of RJ45 receptacles. So this is an example of the patch panel, and this one also, where we RJ45. So this is the patch panel. They are used to bring cables run from individual computer locations to a single location where they can be patched to other equipments using patch cables. A patch cable is simply a short length of twisted pair cable with an RJ45 plug on both ends. Patch cables are usually 3 to 10 feet in length, but longer lengths are occasionally. Next are network cables. So network cables are transmission media to transfer data from one device to another. Okay, so these are the network devices that we usually use in computer networking. There are actually more network devices, but these are the common ones. Okay, so we're going to discuss the other devices and other topics on the next video. Thank you so much for your time. Have a nice day.